We have talked about the chain rule. We will be doing some more problems, but let me also discuss the division rule. When you want to differentiate something like sin x by cos x, you cannot do like this, differentiating the numerator divided by differentiating the denominator. That is simply wrong. Assumptions cannot be made. The rule for this is actually more complicated. First, square of the denominator and then just copy it, differentiate the numerator, put a minus sign and reverse this process, and you are done. That's how we differentiate something upon something type of case. For example, you want to differentiate let's say sin x by x. First of all, square of the denominator, copy the denominator, differentiate the numerator, put a minus sign and reverse the process. Okay, can you tell me what is the derivative of sin x? Answer is cos x. Yes. And can you tell me what is the derivative of just x? One is correct. So x cos x minus sin x whole divided by x square. Okay, so that's how division is handled. While formulae are straightforward for addition, subtraction, multiplication, even division, it is chain rule that requires more practice than anything else in this discussion. Try this problem. Derivative of sin x. I can see that answer cos of sin x times cos x. Okay. Those who are getting cos of sin x into cos x are on the spot. They are right. Now, anybody would like this to be discussed on the board, just raise your hand. Yes, I could notice hand raising. Here we go. This is sin x here. I would like sin x to come here also. But I just can't do it like this. I must use chain. Now that I have got a chain, it is perfect. Mentally you can visualize that these things are cancelling, so to say. This is just for visualizing. Then for your convenience, you can put sin x equal to t. Derivative of sin x with respect to x is cos x. Derivative of sin t with respect to t is cos t. Never give final answer in terms of any variable that you introduce. It's done. Any questions? Just let me know. Alright, I will try to give you more practice. Here comes the next one. Try this. Root 10x. You can raise your hand if you would like this to be discussed on the board. X square x by 2 root x. I think I will discuss it on the board. So here we go. We can approach a problem like this also. We can directly say that let something be equal to t. That answer 1 upon root 10x, that is coming close. In fact, it could be correct. While you type out an answer, it should be clear if it is numerator or denominator. So, are you saying x square x is in the numerator or is it in the denominator? You can use brackets to make it clear what you mean to say, numerator or denominator. Now, as I was saying, you can take something equal to t right in the beginning. Also, perhaps it may look easier to you. Suppose we say let 10x be equal to t. Then how does it look like? This. To differentiate root t, you need t here. And for that you go for chain rule. So making a chain like this. Yes. 1 upon 2 root 10x, sec square x in numerator is perfect. That is the correct answer. Sec square x upon 2 root 10x. 2 root 10x. Now, this root t with respect to t we can handle x to the power n formula. So d dt of root t, then d dx of, in place of t, 10x. Derivative of root t, please check and see if you are getting 1 upon 2 root t using x to the power n formula. Let me know if you have any problem with that. d dx of 10x would be sec square x. Finally, you must get rid of t. In place of t, putting 10x. And we are done. Any questions regarding this whole thing, just let me know. Third step. I am using the pointer. Is it the one you are saying? Select yes or no. In fact, it looks like second one. This is the one. Is this the one that you are saying? Alright. Okay. So that means your problem is d dt of root t. d dt of root t is probably your problem. What is this formula? d dx of x to the power n, that you know. In that formula, put n equal to half. Put n equal to half. And see what you get. 1 upon 2 root x. So that's how we got 1 upon 2 root t. Any questions? Let me know. Alright. So moving on to the next case. Now sometimes you may have difficulty to imagine what should I put as t. How do I know that I should put 10x as t? That comes naturally to you as you practice more and more. After some time it comes naturally. What should be put as t? Let me just make little change and you will see that choice of t will change as I make that little change. Try this. Sec square root x. Just check your last term. That 1 upon 2 after that. Sec square root x 1 upon 2 root x. Yes, that one is correct. Upon 2 root x. Now, if anybody would like this to be discussed on the board, then raise your hand. Okay. Now here you should take root x as t. So you would get ddx of 10t. That means you must have t here. But for that you need chain rule. 10t can be differentiated with respect to t. But t cannot be differentiated just like that with respect to x. So in place of t, putting root x. ddx of root x, x to the power n formula. And finally removing t. Any questions? Let me know. Okay, looks like it is done. So you saw the difference when it was root 10x, then we chose something else for t. When it was 10 of root x, then we chose something else for t. Find ddx of sec of x cubed. Three x square sec of x cubed 10 of x cubed. That's very good. 3x square sec of x cubed 10 of x cubed is the correct answer. If anybody would like this to be discussed on the board, then raise your hand. Okay, there was some private messages going on. So if you would like this to be discussed on the board, then raise your hand again. Or tell me if you have any specific question. In case you raised your hand earlier, I think I might not have noticed it because I was looking at private messages. Sec x cubed 10x cubed, then it should be 3x square. Sec x cubed 10x cubed 3x square. Okay, so looks like if there was any problem, it has been resolved and I can take the next case. Let's make it harder. T alone won't be able to handle this problem. Chain can have several variables in it. The problems that we have taken till now, only one new variable was enough to handle those problems. But this problem cannot be done with just one new variable. So when you start with root x equal to u, then one more variable you would require later on. Sec square sine root x, yes. Cos root x, yes. Upon 2 root x. Excellent. That's good, very good. Fine. Now anybody would like this to be discussed on the board? Just raise your hand. Alright, here we go. So we have d dx of tan of sine u. You can still see that we have a problem. So we go for one more substitution, sine u equal to v. That helps, but we can't differentiate like that. V should be here, if it is v here. So we need to make a chain. So we write it as d dv of tan v into dv by dx. Now d dv by tan v we can handle. How much is that? Sec square v. But d dx of v we can't do it. One is v, other is x. In place of v, we write sine u. We can handle sine u if this is not x but is u. So we convert x to u. But we can't do it just like that. We need to use chain rule. d du of sine u is no problem. So we differentiate it straight away. Cos u. d dx of u can't be done straight away. So in place of u, we put root x back. And then in place of v, we put sine u. d dx of root x is 1 upon 2 root x. Final answer should not be in u. We introduce that variable. U is root x, so sine of root x, cos of root x, whole divided by 2 root x. If you have any questions in this whole discussion, just let me know. So likewise, the chain can become bigger and bigger and bigger. Let me give you one more big problem. Yes, I noticed the private message. Third step. Just see my pointer and select yes from the top if this is what you mean as a third step, or select no. Yes, no, you can see at the top. Okay, I can see that private message. Now, this is the step you are asking. d dx of tan x is how much? Sec square x. So d dv of tan v is also sec square v. d dt of tan t is also sec square t. As long as the two variables here are same, this and that, you can use that formula, sec square of that thing, whatever is here or here. Then we took v as sine u. Look at this marker pen. So I did nothing but just put sine u in place of v. That's it. Let me know if you have any other question. Okay, so looks like we can move on. Try this. I think the first answer is correct. It looks like to me that the first answer is correct. The very first one. Second one has little problem. It says root of sine x. I don't think you will get sine of x. It should be root x only. X won't come alone. Yes, last one also. Last one also is correct. Now, if anybody would like this to be discussed on the board, then raise your hand. Okay? So, first we try with root x equal to u. That gets us d dx of root of sine u. Now we can't handle it straight away. So we go for one more substitution. Sine u equal to v. So we have d dx equal to root v. Root of anything means x to the power n formula. We can handle it. Root of x type of thing we can handle. So we now no longer introduce third variable. Some problems may even require you to introduce third variable. And we just focus on this chain. We focus on chain. So ddx, that I'm writing as ddv into dv by dx. ddv of root v, 1 upon 2 root v. Now I'm going to put back what was taken for v. It was sine u. So ddx of sine u. Now sine u we can handle, but we can handle it if this is not x, this is u. So we need chain rule. So that's done. Now d du of sine u is cos u. And finally, in place of u, putting root x, so 1 upon 2 root v cos u 1 upon 2 root x. Now finally get rid of u and v and get everything in x. That you can certainly do. Now if you have any questions regarding this whole working, then just let me know. Okay. Now, there is little extra that you need to be aware of. Like in trigonometry, we are talking of functions, sine, cos. These are functions. You also have other types of functions as well. A very well-known function is the log function. If you put sine in front of pi by 6, pi by 6 changes its form and becomes half. It is like an operator doing an operation and giving an output. It's like a machine. Sine is like a machine in which you introduce pi by 6 as raw material and it gives you a finished product called half. There are many such mathematical operators. Cos, tan, you know of. Log is a very well known mathematical operator. You have, I think, come across it in pH value based discussion, chemistry. Here, when we discuss log in calculus, then it has a base which is called E. How do we define log? We define log of something for some base. So log x, when we write, it is written loosely. Strictly if we write log x, then there must be some base, absolutely necessary. Talking in the strict sense, there should be some base. When you discuss pH in chemistry, then that base is 10. Earlier, when calculators were not so easily accessible or available, then log tables were used for calculations. And even now you can find log tables, but gradually they are becoming obsolete. If you look at a log table, then those values of log for different numbers are for the base 10. And when we discuss pH also, let's say pH of 10 to the power minus 2 molar H plus ion concentration is how much? pH. Then we say it is minus log of 10 to the power minus 2. Here what is hidden is the base 10. This is what is hidden there. Not shown, but it is there. So when you look at log of 10 to the power minus 2 to the base 10, then it is minus 2. Log of 10 to the power minus 2 to the base 10 is minus 2. But when we do pH calculation, there is a minus sign outside. pH is defined like that. So the answer comes out to be 2, and you know that it is acidic solution. pH is 2. In calculus, this 10 is not used so much for log. Base, I'm talking about base. But some other constant is used more often. and that constant is called E. Just like pi is a constant, E is a constant. While we define pi in a very easy way, take any circle, measure its circumference, divide that circumference by diameter. Divide that circumference by diameter, and whatever you get is pi. That's how we define pi. But when we try to find the value of pi, it is actually a huge series. The value of pi can be obtained by a series, which is a huge series, never-ending series. E is a number which is also given in terms of a big series, and its approximate value is 2.7. That may be good enough at this stage to know this much about E. It is irrational like pi, so it is not equal to exactly 2.7. 2.7 is only the approximate value of E. Like pi is not equal to 22 by 7, but pi is approximately equal to 22 by 7. E is approximately equal to 2.7. Both are irrational numbers, so you cannot write both of them in 2.7 format or 22 by 7 format. E is very important in calculus. Log is a function, it's an operator. Log of 10 to the power minus 2 to the base 10 is minus 2. But if you change the base from 10 to E, log changes its value. Log gives you several values, and when we differentiate log with respect to x, now if I am not writing anything here in calculus, it means it is E. If I am not writing anything here in the context of calculus, it means it is E. Then the answer is 1 upon x. The background of log is not enough at this stage to understand it much more than this. But we will be doing a topic called logarithms later on in mathematics. Then it will make more sense. You do encounter log in physics, that's why we have to discuss this. E to the power x, the same E that I discussed, 2.7 to the power x. When you differentiate that, then the answer to that is also e to the power x. E to the power x is perhaps easier for you to understand. It is just like saying 2 to the power 2.7 to the power x, or just think in simple words as 3 to the power x. How will 3 to the power x behave is easier for you to understand. Put x equal to 1 and you get y equal to y is 3 to the power x. Y equal to 3. Put x equal to 2 and you get y equal to 9. Put x equal to 3 and you get y equal to 27. So e to the power x or 3 to the power x of form is easier for you to understand than log. So when we differentiate e to the power x, then the answer is e to the power x. Answer is e to the power x. Now if you are wondering, why is it not following this particular law? ddx of x to the power n is nx to the power n minus 1. So you might be wondering, why is it not x e to the power x minus 1? And the answer is, in one case it is variable to the power some constant, and in the other case it is constant to the power variable. Never use this type of formula if n is a variable. Never. So if I ask you to differentiate x to the power x, It's not fair to ask it in physics. It's okay to ask it in mathematics. But if you are asked just for the sake of discussing to differentiate x to the power x, never use this formula. That formula is for x to the power constant, whereas this is for x to the power another variable. We can handle such situations, but when we discuss calculus differentiation in mathematics. Okay, so this is something that you will have to remember, that differentiation of e to the power x is e to the power x itself. To have a visualization of e to the power x, we have discussed lots of graphs in trigonometry. I can show you the graph for e to the power x, a very famous function. So let me put the graphing calculator, and I'm just going to type out e to the power x. You will see that even this calculator understands e. That shows the importance of e in mathematics, which is nearly 2.7, number e. That's how e to the power x behaves. If you remember sin x, up down behavior, e to the power x is not up down, it's rise and rise and rise. Like population rises, generally speaking, quickly, we use the word exponential growth. Bacterial growth, exponential growth. Growth is, exponential word is associated with growth. That's exactly what e to the power x is. Exponential function it is called. So I think from physics perspective, this should be enough. And let me illustrate this to you, how what we have discussed regarding calculus, differentiation part, could be applied in physics. There is a private message about hyperbola. Well, hyperbola would look like this. In fact, there are so many types of hyperbolas, but generally speaking, hyperbola has two parts. You don't have hyperbola which has only one part. Hyperbola has two parts. The curve that I have drawn below, in different color it is shown, you can see it has two parts. Hyperbola will always have two parts. E to the power x has just one continuous smooth line starting from one end to the other end. Now regarding that illustration from physics perspective, in physics, we always talk about rate of change of one thing with respect to the other. The easiest thing for you to visualize is speed. ds by dt. You also understand current very well. So current based problem also you can understand. Current is dq by dt. In earlier classes you might have learned it as charge upon time. But again, if charge keeps on fluctuating up, down, it always makes sense to talk about instantaneous things. Instantaneous. Like for example, in your home, current is never fixed. You may not be aware of it. Visibly it does not look like that. But actually current is changing so rapidly that what is the value of current at an instant? So difficult to answer. You know about AC idea, right? Alternating current. Even voltage. It's all continuously changing. So when we talk about instantaneous voltage or instantaneous current, then we need to use calculus. So I equal to Q upon T perhaps may make sense in DC circuit when a battery is connected like a torch, when a battery cells are connected to some bulb and fixed current is going for some time. Fixed charge is traveling for some time. That's fine, but in case of AC circuits, every instant, fraction of second, current is different. So that tells you about the importance of calculus. Current is dq by dt, not q by t in such cases. Suppose we have some circuit called RC circuit. R for resistance, C for capacitance. And in that RC circuit, current is given by I equal to some fixed constant multiplied by e to the power, the same e that I mentioned to you, minus t by another constant R, resistance, another constant C, capacitance. Resistance you know very well. Capacitance you must have heard about. Capacitor is there in fans, it is there in every fluorescent lamp, CFL or tube light. In fact, it is in huge numbers in any integrated circuit that you I mean any PCB that you take, which has so many ICs and it also has so many capacitors. I0 is fixed, R is fixed, C is fixed. Find the rate of change of current at t equal to 0, at t equal to RC, at t equal to 10 RC. Rate of change of current, that is di by dt. So di by dt is asked. It's simple differentiation. So you just have to differentiate this I0 e to the power minus t by RC. What about constant? When you differentiate, doesn't it come out? Constant alone is 0. Constant alone is 0. But constant is multiplied to some function here. The constant will come out. And then we have d dt of e to the power minus t by RC. I hope it is okay up to this point. Any questions? If you have, let me know up to this point. No questions. Now, it is not just e to the power x type of case. So we must use chain rule here. So let's put minus t by RC equal to some variable called u. So we have I0 d dt of e to the power u. E to the power u we can handle, provided we have u in the bottom. d du of e to the power u is okay. Applying chain rule, du by dt. d du of e to the power u we can handle. It will be e to the power u. In place of u, we put this thing which is minus T by RC. Now resistor is constant, capacitor is constant. So what should we do here? We should take R and C out of differentiation sign. I naught e to the power u minus 1 upon RC is out, right? And then we have d dt of t. But d dt of t is 1. So minus I naught e to the power u by RC, d dt of t is 1. Just get rid of u. And what was u? Minus T by RC. E to the power x graph that you saw is very important in physics. It comes, in fact, e to the power minus x graph. E to the power minus x I did not show you. E to the power minus x is very important. This is how e to the power minus x looks like. Look at that. You see that falling type of graph. So exponential growth is e to the power x. This is the fall. E to the power minus x is the fall. It's the falling type of graph. Okay, now I think we are done finding differentiation. So that's di by dt. And now question is asking you, find that value for different times. Find that value for different times. So first put t equal to 0 here. That you should do. Put t equal to 0, see what you get. That's the answer to part A. Put t equal to RC, you get the second answer. Put t equal to 10 RC and you get the third answer. Values are put only after differentiation. Yes, first answer is minus I naught by RC. You see, t will not come in the answer because you are putting different values for t only. Let me give you the answers now. When time is 0, rate of change of current is minus I naught by RC. When time is RC, then rate of change of current is minus I naught by RCE. and when time is 10 times RC, then it is minus I naught by RC e to the power 10. If anybody has problem with these three parts, up to here I have discussed. Okay, even up to that, if you have any questions, let me know, or after that, if you have any questions, let me know. Now what is important is that if you are asked di by dt at certain time, then don't put first and then differentiate. For example, don't do like this. Putting t equal to 0 gives us I equal to I naught e to the power 0. Any constant to the power 0 is 1. So at t equal to 0, current is I naught, and then say that di by dt of a constant alone is 0, and therefore the answer is 0. Never do it like this. We don't put the value of t first. We first find di by dt. If we wanted current at t equal to 0, what is the current at t equal to 0? Then you will put t equal to 0 here. You are not asked what is current at t equal to 0. You are asked what is the rate of change of current at t equal to 0. So first you would find rate of change of current, and then you would put t equal to 0. So we found di by dt first. Okay, we stop at this point.